Welcome to my channel. Today we are looking at integration of double functions. How do we integrate two functions? You know, it is pretty easy to integrate x cubed, so x to the power 3, by using the formula where we just add a 1 to the power and divide the result. Then we get x to the power 4 over 4. It's pretty easy. So what will happen if we have a function like this one? Integrate x squared e to the power x dx. The formula will not just be used on this one, where we add the powers. Since we have two functions, we have x squared and e to the power x. Therefore, the formula cannot work. So what do? This is where now we use what we call integration by parts. So what is this integration by parts? Let's just take a brief history of how it came about. So when you look at differentiation of two functions, for instance, you have u and v as functions. When you are differentiating these, we have what we call the product rule, the formula that we use to integrate two functions, to differentiate two functions. So you have u dv over dx plus v du dx. Now from this same formula, mathematicians thought of deriving another formula which we can use when differentiating or when integrating two functions, called differentiating by parts, integration by parts. Okay, so since we are looking at integration, we are going to introduce integrals to each of these. So integrate the integrals, and when you introduce integrals, you have to put dx. Okay, so this dx will cancel out, and the d with that goes will remain with this, is equal to the dx and dx goes, you remain with an integral of u dv plus integral of v du. So since we want to integrate, we are going to pick something with an integral. So we have two parts that have integrals. We have this and this. So we are picking this one, the integral of u dv. So we make it the subject of the formula. U dv is equal to uv minus integral of v du. So there you have it. This is now the formula that we'll be using when integrating two functions. It's a formula for integration by parts. Okay, now since we have this, we can also note that inside this integral, inside the integral here, we have two functions. The one function is u, the other one is dv. So meaning when we are told to integrate x squared e to the power x, you have to manipulate these two functions, e squared and e to the power x. One must be u, the other one must be dv, to suit what is inside the integral. Okay, so what are we considering to be u and which one will be dv? Before you choose, you have to analyze which one will easily be differentiated and which one will easily be integrated. So when you look at these two functions, you will discover that u can be easily differentiated. So u will be x squared. So I mean x squared can easily be differentiated. And then e to the power x can easily be integrated. So dv is e to the power x. So from this we have du dx is equal to 2x, and the integral of e, which is v, is equal to e to the power x. So using this information, we are going to fuse in the formula above here, where we should put what belongs to u and dv, u, v, and du. So let's begin. So here the solution will be u is x squared, v is e to the power x, then minus the integral of v du. So v is e to the power x, du is 2x. Okay, so let's try to integrate what is inside there. So we have x squared e to the power x minus the integral of 2x e to the power x dx. So if we observe inside this integral, you have two functions, 2x and e to the power x. Therefore, as we said, integrating two functions will require you to use the formula for integration by parts. So this part here, we are going to integrate it using that formula for integration by parts. So we're going to copy x squared ex minus, then we have uv minus the integral of v du. Okay, so at this point, we know that we are trying to integrate 2x e to the power x. So we should relate which one is u and which one is dv. So we are choosing 2x to be u and e to the power x to be dv. So let's see what we get. So u is equal to 2x, dv is equal to e to the power x, giving us du dx equal to 2 and v equal to e to the power x. Okay, so let's continue. So copy this minus, what is our u? Our u is 2x times v is e to the power x, minus the integral of v is e to the power x times dv, which is just 2 dx. Okay, so continue, x squared e to the power x. Then we distribute this negative. We have 2x e to the power x. Negative times negative is positive. We can put out these 2, we remain with this inside. Okay, so what will be our final answer? Since now inside the integral we only have a function which is integratable, so we can integrate e to the power x. So let us copy that, x squared e to the power x minus 2x e to the power x plus 2 times the integral of e, and the integral of e power 2 is e power 2, so 2 e raised to the power 2 plus c. Since we are doing an indefinite integration here. So that is how you go about the integration by parts, integrating two functions. Okay, now guess what? We have an even pretty easy method to use called the DI method. So how did this one come about also? So from the formula of differentiation by parts, we can just note certain behaviors of the formula as we go about integrating. You'll discover that when you start integrating with the formula u v minus integral v du, after integrating all this, you still to function inside the integral. You should also redo the same formula of differentiating by parts. If it goes on like that and is still leaving two function inside, you again redo the formula plus u v minus the integral v du. So let us observe what is happening. Look at the signs. So we have positive here, negative, positive, negative, positive, negative. So the signs are actually alternating. That is one thing we note. The other thing that we note is we are choosing two functions. We are choosing one of these two functions. The other one should be u, meaning it has to be differentiated. The other one will be dv, which has to be integrated. So we have d and I, differentiation and integration. So therefore, we put d and I. Then look at the signs. We are starting with positive, negative, the alternation. So you also alternate them just here. Plus, minus, just like that. Okay? So you choose to differentiate, which is u x squared under d, and integrate e. So it should be under I for integration. So let us see how this one works. Here it is, the DI method. So as I explained the signs, okay. So when we put we choose the function to be differentiated, which in our case is x squared, and e to the power x to be integrated. So we keep differentiating x squared until it gets to 0. So this is type 1. There are other types where you can differentiate but still not get to 0. So there is something that we do about that one. There are certain rules that we consider. So you will see that in my next video. So today we are considering the differentiation that will take you to 0. So when you differentiate x squared, you have 2x. Differentiate 2x, you have 2. Differentiate 2, you have 0. So you end there. Then keep integrating this part, you integrate that, you get the same, integrate, you integrate. Then after you have done that, you have to multiply the top differentiated and the second integrated. You multiply the second integrated and differentiated with the third integrated. Third differentiated with the fourth integrated. So when multiplying, you consider the signs. So x squared is positive there. So you can say positive x squared times e to the power x is what we get here. Here we get 2x, which is minus 2x times e to the power x. Here we get positive 2 times e to the power x. Afterwards, you just connect this. The first one is x squared e to the power x, then this one minus 2x e to the power x, then this one plus 2e to the power x, then plus c, since it is an indefinite integral. There you get it. So that is how easy the DI method works. Thank you for watching. Be sure to join me in the next videos and subscribe for more videos of this kind. Thank you.